Okay, guys. So we're getting into electric current, and with this we have to know and understand Ohm's law. So Ohm's law is the law that as we were just discussing, kind of governs our electric current. So these are the symbols that you need to know. Voltage, all right, is represented by a capital V. Its unit is the volts, which is a capital V as well. Capital I for current. That is measured in either capital A, you'll see that, it stands for amps or amperes, or you may see it just written as amps. And capital R is for the resistance, which is the Greek symbol ohm, all right, the Greek symbol omega, which is for ohm, okay, it's kind of like an upside down horseshoe looking thing. And then you have Ohm's law's triangle. So the way this works is, right, if I ask you to solve for voltage covering up V equals, if they're next to each other, it's I times R. If I ask you to solve for I is equal to what's left, V divided by R. And if you were looking for R is V divided by I. Similarly, how we've used the triangle all year for any one of our things. So here is just a basic setup of a circuit. Okay, this outer piece is pretty much our wire through which the current is moving. This symbol here, we kind of have a short and long piece here. All right, that is our battery. Now the battery is going to be equal to our total voltage. So voltage with a subscript capital T for total voltage. These little symbols here are resistors, all right? Something that's going to be using this current to kind of power it and make it work. This little squiggle material or symbol, all right, that's a resistor. All right, the first one, and we will label them as R1, R2, R3, etc. as we go. As we continue through a wire, if you see something like this, if you see a symbol like this with a number and a capital A, or it may say lowercase a on some sources, okay, that is an ammeter. It measures the ampage, all right, which is therefore is measuring our current. That measures the current. Then you have a certain resistor, you have a second resistor. If you see this, what this stands for is a voltmeter, which measures the amount of voltage, all right, that measures the voltage drop or the amount of voltage, okay, that is basically going through that resistor at that time. All right, the electrons move through and basically kind of just continue around. Now this is a very basic example of one, okay, which would be a series type of circuit. So what makes something a series type of circuit? Well, electrons only have one path to flow through. So the current would be the same everywhere. The electrons only have one path to go from start around to finish. All right, there's only one path. They have to go from here through the first resistor, here, all right, through the second resistor. Now note, this is not part of the circuit itself, nor is this. Those are there to help, all right, give us little readings on certain pieces. It gives us more information to help solve for problems. All right, so again, battery is our total voltage, okay, R1, R2, R3. This is an example of a series circuit. So in our example here, where we have a 12-volt battery, our total voltage, you have resistors of R1, R2, and R3. All right, they're going to ask you to solve for a couple different things. Now, here are the rules for series circuits. The total voltage is equal to the voltage drops everywhere. All right, the voltage going through here, the voltage going through here, and the voltage going through here. So think about this almost as like this is a road and there's a toll. All right, every time you go, or Monopoly kind of thing, right? You go from finish to start, you get 12 volts worth of currency. You have to, all right, spend it all in order to get all the way back. So you have to, spend a certain amount of volts here, spend a certain amount of volts here, and spend a certain amount of here, and then kind of go back, if that's an easy way to think about it. All right, so How do I know what's V1? Voltage 1 goes with the resistor 1. That's just going to be exactly how it works. Voltage 2 goes with resistor 2, and if there's more than that, then V3 is going to go with R3. V4 we go with R4 if there's that many. Now, the current. The electrons only have one path to take, so the current is the same everywhere. So the total current is equal to the current going through the first resistor, going through the second resistor, and the third, etc., because it's the same amount of electrons going through, like each point. All right. So if you know, like you saw this, and this, let's say, said like, oh, it says 2 amps. All right. Well, guess what? That's the total current. That's the current through I1, I2, I3, etc. Now, the total resistance for a series circuit, all right, is the equivalent. Sometimes you may see it as REQ, equivalent resistance. All right. I use total resistance. All your resistor values added up is equal to the total resistance. Okay, and if you know what the total is, and 2 of them, but not the third, you can take the total minus this guy and this guy, which would tell you what the missing is. All right, so how do we go about and solve this? So for you guys, how I'm going to be making these problems is you guys are going to be completing a VIR table. All right, now you have this kind of worked out in front of you, but what you would do is we would write VIR like that, and then we make a table. This is just going to be easy to do, and it will help you solve for all of them, anything that you need out of them. All right, so you make as many rows as there are resistors. We have 1, 2, 3 resistors, so you're going to make a 1, 2, 3. If there was only 2, you would only do 1, 2. And then after that, you do a total for the total resistance, total voltage, total currents. Okay, we make our table. So you guys are going to do 2 things. All right? You guys are only going to do, all right, you're going to basically use the rules and the triangle. So if you have 2 values in the same row, you're going to use Ohm's law's triangle to find the third and missing piece. Bless you. All right, so here's how we would go about it and go through this. Boom, boom. There it is. Okay, so what information do I have? I have 12 volts over the battery. We said up here, that is our total voltage. I love when they give me that. So VT, total voltage is 12. 12 volts. Okay, what else do I have? I have R1, which is 50 ohms. R2, which is 100 ohms. And R3, which is also 100 ohms. All right. Now, missed the bar. I don't know what to do here. Okay. I can't use the triangle yet because you need 2 values in any row, right? Because if I knew current and resistance, I can multiply them together to find the voltage. I don't have any currents. All I have is resistances and these guys and total voltage here. So if you don't have 2 in any row, then what you need to do is you have to use the rules. One of the rules will give you a piece of information. So let's look at our rules. Okay, the total voltage is equal to the V1, V2. I don't have that, so I can't use that yet. I don't know what the current is yet because I don't see an ammeter anywhere that gives me that. So what do? Well, let's see. Do you have all the resistors given to us? We have 50, 100, 100, right? Do we have all of them? Yeah. So because we have all of them, all right, we can do the total resistance is equal to R1 plus R2 plus R3, which would be 50 plus 100 plus 100. And so your total resistance would be what? 250. So we have 250 ohms. So now we can take that and we can add this here. I'm going to highlight the ones in yellow that we had to solve for. Okay, now what do I do? Can I use the rules again? No, we've already used, right? We said we couldn't use this rule, we couldn't use this rule. So now what do I do? All right, so like I said, once you have two values in the same row, use Ohm's law's triangle to find the third. So that is what we're going to do. We have two here in the same row. We have resistance and voltage. So Ohm's law triangle, which is up on the top of your notes, okay, what is our missing value? Is it voltage, resistance, or current in the total row? I. So we can solve for IT, the total current. How do we do this? If I cover up I, we're going to do V divided by R. So V divided by R. But you can't just use any V and any R. You have to use the one that's in your row. The voltage, resistance, and current for the first. Okay, the resistance for the second resistor, current and voltage. Third resistor, current and voltage. So we can't just be like, oh, we're going to use 12 and 100 or no. All right, since they're in the same row, that's what we have to use. And so again, the equation was covering up I, V divided by R. But you have to use VT and RT. Total voltage was 12. Total resistance was 250. Okay, this came out to give us a value of 0.48. And the unit for current is amps. So now, where can we put that? In the IT, all right, spot. So we found that. All right. So now, okay, cool, I got that. That makes sense, Mr. Navarro. But now what? I don't have two in either row, so I can't use the triangle again yet. So remember, you're literally only stuck with two options. You're either going to be stuck with the rules or using the triangle. When you have two in the same row, what do? Triangle. All right? When you don't, either the drawing or the rules are going to give us the information. So we already used this rule. I still don't know any of the voltages across these resistors yet, so I can't use VT. What about IT? The total current is equal to the current going through the first resistor. It's equal to the current going through this. They're equal everywhere. So guess what? No math needed. All right. We have our 0.40. I'm sorry. This should be 0.048. So let me get rid of that little guy. 0.048, 0.048, and 0.048 amps. Why? Because the current is the same. So once you find the current in any one of these spots, they're all going to be the same. That's super awesome. That's super easy. That's basically just straight up, okay, from our rules. All right? That's straight up from our rules. So now what? Right? We found that all of these were the same going up. So boom, boom, boom. Okay, can I now use the other rule? Can I use the voltage rule here? No, not yet. But what do I have? I have two in this row. I have two in this row. I have two in this row. When you have two in the same row, what are you going to do? You're going to use the triangle. We're going to use the triangle. So how do you solve for voltage? Cover up V, and you're going to get I times R. And so that is what you would do. But you have to go, all right, V1 is going to be I1 and R1. So V1 is I1 times R1. So you're doing this 0.048 amps, right? That's the I times the resistor of 50. And this kicks out an answer of 2.4, and the unit for voltage is volts. V2 is I2 times R2. So again, it's the 0.048. This time it's times 100. So that will be 4.8. And V3 is I3 times R3. So 0.048 again times 100. We don't have to actually type it into a calculator again because it's going to be the same answer here. All right, but you still need to show your work. And now we can take these guys and put them in their correct spots. 2.4 volts, 4.8 volts, and 4.8 volts. But I do want to make sure I mention this. The total voltage, all right, the voltage drops, V1, V2, V3, they need to add up to equal the total voltage. And when we throw this into a calculator, all right, they do add up to be equal a total of 12 volts. So with that total of 12 volts, these values are good. On certain problems, they're not going to be quite as equal, all right, because of rounding. So you would need to round them in order to make sure that these guys would add up to the total voltage. So out of the values or the things that you found, right, we found this guy, this guy, this guy, boom, boom, boom. So you guys will be asked to complete these series circuit problems, all right, by making a VIR table. All right, an Ohm's law table, all right, a VIR table, and that is how we're going to work through those, okay? So if you guys go to now this paper here, all right, we're going to go to this paper here. Everybody cool? So on this paper, we are going to make a VIR table and complete this. So put a little star. Again, if you know two values in the same row, use the triangle to find the third. Okay, VIR. Okay, I is V divided by R, and R is V divided by I. Okay, the rules. The total resistance is equal to all the resistors added up. The current is the same everywhere, which is why they're all equal. And the total voltage, all right, the total voltage is the voltage drops added all together. So on a separate sheet of paper, guys, your graph paper that you have out in front of you, that's what this is for, okay? A couple of things to remember. Current is the same at every single part of the circuit. The voltage supplied by the battery is the total voltage, and the voltage drops across each resistor adds up to that total voltage. And then to calculate total resistance, we add all the resistor values. So right now, we are going to complete table, all right, circuit 1. So on your graph paper, you guys will pretty much do number 1. And we're going to make a VIR table for this. So again, this is for the series circuits here. All right, so we have to make a V, an I, and an R. All right, now, how many resistors do you see? 2. So you're going to make a 1 and a 2, and then please let's work on this. All right. So for the first circuit, we start a VIR table. There's only 2 resistors, so we go 1, 2, and then a T for the total. There will always be a T. However many resistors are, that's how many, all right, rows we're going to make. And we just pretty much do this. All right. Give ourselves some room to write these things in. All right. What information do we have given? What information do we have given right here, guys? The 10 and the 20. So R1, we go for R1. We're going to put that as 10 ohms. R2 is 20 ohms. So for R2, we're doing 20 ohms. And then what is the only other thing we have? And I labeled it for you guys on here. This symbol right here is the battery. And we have a voltmeter across this. And it is, all right, our total of 90 volts. Okay. Now, how do we do this? What can we do? Do we have 2 values in the same row right now? No. So we can't use the triangle yet, which means we have to use, all right, one of our rules. All right. Now the rules are also at the top of the paper, but so actually let me scooch this up for a second. Okay. The voltage drops across. Well, we don't know what these are, so we can't add them up. We don't have current yet, so we can't equal them all out, but we do have both the resistors, all right? So if you have all the resistors, you can add them all together to find RT. So that's going to be the first thing that you're going to need to do. So RT is going to equal R1 plus R2, and that is going to equal 10 plus 20. 10 plus 20 is going to be equal to 30 ohms as our total resistance. So we can take that 30 here and put it here. All right, so once we have that, boom, we've got that completed. Okay, so now, can I use any of the rules still? Any of the rules again? I've already used the first one. I've already used the resistance, all right, total resistance rule. I still don't know the current, and I don't know other voltage drops. If I knew this one, I could do 90 minus this to find the second, but we don't. So, what do? If you have two values in the same row, use the triangle. Okay, so the triangle is VIR. I don't know what I is. If I cover it up, it's going to be V divided by R. So, and which one is it? IT. So, total current is equal to the total voltage divided by the total resistance. The total voltage is 90. Total resistance is 30. Dividing those out is going to give me 3, and the unit for current is amps. So we can take this in and place it here. All right, so when we have that, if we have that, okay, can I use the triangle again in these two to find either one of these guys? No, because I don't have two in the same row. So now, again, we got to go back to the rule. All right, rule, picture, all right, triangle. So we don't have two in the same row, we can't use the triangle, but let's go back to the rules. Once I know the current anywhere in a series circuit, because the current only has one way to go around, it's going to be the same everywhere. All right, that was part of my rule. All right, so the current is going to be the same everywhere, so it's 3 amps and 3 amps. All right, that is based off of the rule. Now, what can I do? Now, what can I do? If you know, all right, two values in the same row, use the triangle. So, do I know two values in the same row? Yeah. All right, I have I1 and R1. So can I find V1? Yeah. How? Covering up V. It's I times R. So V1 is I1 times R1. I1 is 3. R1 is 10. Multiply those together, we're going to get 30. And what's the unit for voltage? Is volts. And if you need to find V2, voltage is current times resistance, sheesh. All right, so we're going to take current 2, all right, I2, and resistance 2, R2, which is 20. 3 times 20, that is going to give me 60 volts. Now, just a quick check, the voltage drops, all right, your V1, V2, V3 all should add up to the total. Let me just do a quick add up real quick. 30, yeah, that's 90, which matches the totals. All right, so we're good. This 60, it works. All right, boom, boom. All right, so now we're going to look at, if we look at the second one, Table 2 is going to be done just like, all right, our example problem and the first one. All right, so we're going to I'll give you guys some time to work on that one. We're going to make a quick VIR table for that one. How many resistors would you make, or how many rows are we making? 3 for each of the resistors. So we're going to write a 1, a 2, a 3. And is that all I do? No. What else do I need? A total. Okay, excellent. So, because this one is going to be has been done or is done the same way as our other things, all right, we're going to kind of skip over that one for now, and we're going to look at one that we kind of haven't seen. So your work can be done, okay, to the right side of it. So we're going to look at number 3 right now. So for number 3, and then I'll do the other, we could do 4, 5, and 6 on the back side. So for number 3, we're going to make, again, a VIR table. All right, how many resistors do you see in this one? For number 3, how many resistors do we see? 2. So we're only going to make 2 rows and a total. Excellent. Boom, and boom. All right, what are we given? What are we given? So up here I wrote this symbol, right? That symbol is going to be your battery, which is always the total voltage. So do we have that? We do. We have 75 across the battery. So 75 is going to be our total voltage. What else do we have? We have R1, which is 10. So in position of R1, we're going to put 10 ohms. And we see this guy here. And we see this guy here. So where does that one go? Well, that would be a very valid question, but on a series circuit, it doesn't actually matter, okay? Why? Because the current is the same everywhere. So we can put that at, 1, or start it off at the total current. But they're all going to wind up being 5 amps. Now, I don't like that they put on this that they're doing lowercase a. We're going to use capital A. So I'm going to put that for the total. All right, and so if I held it here as, okay, this is all the information that I have. Is there anything else? All right, I see a 75, got the 10, got the 5. Is there anything else we see? The 25. And what is it over or across? R2. So where do you think this 25 volts should go? Not in R, because the R's need to have the ohms. Voltage. So which voltage is it going in? Voltage 1 or voltage 2? Voltage 2, because it's going across resistor 2. All right, very good. All right, so that's all my given information. Right now, that is all my given information. So what can I do? Right now, I have... All right, now this one's cool because you can do this one a couple different ways. You can do this one a couple different ways. I don't have 2 in this row, so I can't use a triangle. I don't have 2 in this row, so I can't use the triangle, but I do have 2 in this row, so I could use the triangle here. Okay? I should also note that the voltages need to add up to the total. So, because there's only 2, and I know basically it's basically saying blank plus 25 needs to equal 75, you could subtract to find this. Okay, we also should know, look at the rules, that the currents are the same everywhere. So we could then do, all right, 5 here, okay, multiply to find that. All right, so 75 minus 25 would be 50. But if you go this route, where the currents are all the same, all right, we did that, boom. All right, currents are always going to be the same. Now, when I go back and look at it, all right, we have, all right, now we have 2 in each row. So we can do that. We could still do 75 minus 25 and get 50. All right, that's simple. Or we can do this way, where the V1 is equal to the I1 times R1. So we could show that the current is 5, the resistance is 10, and if we multiply that out, that is 50 volts. We could have also shown, right, the total voltage minus V2 would equal V1. 75 minus 25 equals 50, right? Like, that's another way we could have gone through that. All right. Now here, we still don't know what R2 was, but we do have two of the missing pieces. So if I want R2, I got to use the triangle. Okay. Ohm's law's triangle is, if I'm covering up R, V divided by I. V divided by I. But it's V2 divided by I2. V2 is 25. I2 is 5. And so 25 divided by 5 is going to give me 5 ohms. Okay, and then there's two ways you can solve for RT. The total resistance is equal to all the resistors added together. So I could literally just do 10 plus 5 and get 15. Okay, which is going to be the answer. Or you could also do 75 divided by 5. And, right, RT would be VT divided by IT. 75 divided by 5 is, it's 15. But I'm going to go with the super easy one right there. And I'm going to just do, the total resistance is equal to all the resistors added together. So 10 plus 5 is 15 ohms. All right, so you are using, like I said, guys, either you're using the triangle if you have two in the same row, you have the rules, which should help you figure out some stuff, and you have the diagram itself that you need to take the information off of. Okay, so these would be the final answers. All right, everything in yellow is something that you found either from, using the Ohm's law triangle, or using a set of the rules. All right, so let's try. All right, we have 4, 5, and 6 left. We have 4, 5, and 6 left. Again, I think the ones that have all the resistors, all right, we've done a couple examples like that, so I don't think we should do 5. But let's see, what else do we have? I don't know. We're either going to do 4 or 6. I think 6 would probably be the one that's a little bit more on the confusing end. All right, I think 4 would be the one that's a little bit more on the confusing end. I'm sorry, 6. So let's, all right, on my back piece of paper, right, I would have number 4, V, I, and R. I'll just quickly make those tables. There's only 2 resistors here. 1, 2, and a total. All right. 5, V, I, and R. All right, we have 1, 2, and 3, so we're going to make a quick 1, 2, 3, and then T. All right, and then 6, which is what we're going to do as our last example, and you guys are going to kind of finish those out. So for 6, we need to make our VIR table. So we have V, I, R. How many resistors do we see in number 6? R1, R2, R3. Okay, so we gotta do 1, 2, 3, and T. All right. So what information, guys, do we have from this? What numbers do they give us? 40, 10, 20. Okay. What letters do they have? What units? They have voltages. So guess what? They're going to go in those positions for the voltages. So because you have 10 volts over resistor 2, that 10 volts is going to go with V2. So for V2, we're going to have 10 volts. What else? We have 20 volts. What is that going with? Resistor 3. So where should we put the 20 volts? Yeah, in V3. Good. And then, like we said, battery is always going to be your total voltage. So this 40 has to go with VT. All right. And what else do they give us? No R1. I don't see an ammeter around. The no R2. Aha, they did give me R3. And they said that R3 was 10 ohms. So for R3, we're going to put in 10 ohms here. Okay. So that's all the information that's based off of our piece there. So what do you want to do first? There's basically only, you got 2 moves that you can do. All right. So how do I know? That's going to be the main question, guys. How do I know how to fill in the missing spots? How do I know what to do? So again, guys, there's only 2 options. All right. You take the information from your picture. All right, and then you are either going to use one of the rules, or if you have 2 values in the same row, okay, use the triangle to find the third. Okay, so let's see. What do we got? Do we have 2 in the same row? I'd say yeah. So we can do that. Do you want to do that one? Or what else? Because right now we don't know any of the resistors, so we can't, besides one of them, so we can't add these 2 together plus 10 and get the total. Can't use that one. Right here, you can't use current because we don't know what that is, so we can't say that they're all equal. But what about this one? The total voltage is equal to all the voltages added together. But you already know the total. So what could you do? Subtract. So you could do it that way. All right? And so to find V1, you would do the total voltage first minus those 2 to get that. So total voltage minus V3 minus V2. All right, so pretty much 40 minus 20 minus 10, which equals 10. 10 volts. All right, so pretty much if you're only missing one of these guys, y'all. All right. You can take the total minus the other guys, and it will equal your missing value. It didn't matter if you were missing V1, V2, V3. If you knew the total and 2 of these guys, you could subtract to find the missing. If you were given all 3 of them, you can just add them together to get 40. All right, based off of the rule here, all right, the total voltage is equal to the voltage drops. Okay, you could have done that move first. Now, you're only left with one actual other move that you can do. Because we don't know the currents still, so we can't say that they're all equal. And we don't know the rest of the resistances, so we can't add or subtract there. So again, if you can't use a rule, you go to the triangle. All right, which says right here, if you know two values in the same row, use the triangle to find the third. Which row do we have that we have two values in? Row 1, row 2, row 3, or T? 3. Okay, so we need to find which one? Do we need to find V3, I3, or R3? I3. So if I cover up I, get it over here for a second. All right, if I cover up I, it's V divided by R. But we need to make sure we're looking specifically for I3. So I3 would be V3 divided by R3. Okay, so what are the values? What was V3? 20. What about R3? Bingo, bango, bongo. And what is 20 divided by 10? Yes, correct, 2. All right, now what's the unit for current? What's the unit for current? It's on this paper, your notes. Current is capital I is the symbol for it, but what is the unit? A, amps. 2 amps. All right, so we found that. We found that. Okay. Cool. Now, where do you go? How do I find the missings? Well, again, let me ask you guys. Do you have two values in the same row anymore? No. So if you can't use the two in the same row and triangle method, your other information has to come from the rules. So what did we just get? We just got 2A, can't, right? Our current. So, hey, just like this, or on your notes that I gave you guys, current is the same everywhere. So as soon as you find it in one spot, no math needed, you're literally just putting everybody else in the current row or column as 2. Boop, boop, bing, bong. Let's go next. All right. So now we've got these guys. All right, because we found that one, so those are the same based off of the rule. And now, what can you do? Well, oh snap, I got 2 in this row, I got 2 in this row, I got 2 in this row. So row your boat right to Ohm's Law's triangle, and let's solve these problems. All right, R1, how do we solve for R? If I cover up R in the triangle, what does it equal? V divided by I, right? Covering up R, it's V divided by I. But what R am I solving for first? I'm going to go with R1. So you have to use specifically, right, V1 and I1. So V1 and I1. V1 was 10. I1 is 2. What is 10 divided by 2? 5 ohms. Okay, now if I need to solve for R2, D2, just kidding, R2 is V2 over I2. I almost put V2 over R2. V2 is also 10, and the current is also 2, so this is going to be the same answer. All right. And then you have this. I have 2 in the same row, so I can continue to do this, or I can also use the one of the rules. Which rule could I use? The resistance rule, which would state that the total resistance is equal to all your resistors added together. So I could literally just do 5 plus 5 plus 10, get the answer, and put it down. Or, okay, I could do, all right, RT is VT divided by IT. All right, you'll get the same answer. I'm going to show it both ways really quickly. All right, first let's show the adding. Okay, 5 plus 10 is going to give us our 20 amps. Okay, as our, 20 ohms. Whoops, 20 ohms. And then you could have done it, all right, because of the Ohm's law triangle, RT would be VT over IT, and 40 divided by 2 is also going to give you 20. So either way, either method works, okay? So there will be some times where you can use either or. You could use a rule, or you could use the triangle, all right? 2 in the same row, use the triangle. It's up to you on how you want to do it, okay? So again, the reason why we didn't do number 2 is because number 2 was done exactly like, all right, our example problem that we did, okay? Our example problem that we, had here for this guy, for that circuit there. So number 2 is pretty much the same method, same way, okay? You have all the resistors and the total voltage. You add the total resistances up to get, or all your resistors to get the total resistance. And then you can find the current, all right? Then you were able to find the current using the total current, all right? 2 in the same row. So you would have had 12 and 250. Divide those out to get your current. Current rule, all of them are the same. And then to find the missing voltages, you multiply current times resistor, current times resistor, current times resistor in order to get those. All right. So you guys have to complete. All right. You guys will have to complete. We didn't do numbers. Which ones? We didn't do 2, 4, or 5. You guys, I would like you to please complete full VR tables for those. All right, for those 3 problems. 2, 4, and 5. All right, so 2 and 5 are done just like your example. This guy here, all right, you have 2 resistors, so you can add to find the total. You'll know what the total current is. All the currents would be the same. And then to find all your voltages, current times resistor, current times resistor, current times resistor, etc. Okay? Let me just end this video. Where are you at?